Welcome to 7th grade math. We're going to find all the prime numbers that are less than 100. We're going to cross off 1 since a prime number is a whole number greater than 1. And 2 is a prime number. And since multiples of 2 are not prime, cross off all even numbers. So you see we've crossed those off. And circle the next prime number of 3. And since multiples of 3 are not prime, cross off every multiple of 3. So 9, 15, 18's already done, 21, 27. Remember, some of these are already crossed off because they're even. 39, 45, 51, 57. And circle the next prime number of 5. So then we'll cross off all the 5s. And continue circling prime numbers and crossing off their multiples until you are done. So 7, 49, 77, 91. We have 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Those are your prime numbers less than 100. There's only one way that 2 can be expressed as a product of whole numbers. The grid to the right shows there's only one way 2 squares can be used to form a rectangle. So 1 by 2. Using your grids, make as many different rectangles as possible containing 3, 4, 5, 6, 7, 8, 9, and 10 squares. So for 3 squares, we have 1 by 3. For 4 squares, we have 1 by 4 and 2 by 2. For 5 squares, we have 1 by 5. For 6 squares, we have 1 by 6 and 2 by 3. For 7 squares, we have 1 by 7. For 8 squares, 1 by 8, 2 by 4. 9 squares, 1 by 9, 3 by 3. 10 squares, 1 by 10, and 2 by 5. And which numbers of squares can be made into only one rectangle? 3, 5, and 7. Which number of squares can be made into more than one rectangles? 4, 6, 8, 9, and 10. Factors, 2 or more numbers multiplied together to form a product. So we know that. What are the factors for each set of squares? So for 3 squares, it's 1 and 3. For 4 squares, we have 1 times 3 and 2 times 2, so it's 1, 2, and 3. For 5 squares, it's 1 times 5, so it's 1 and 5. For 6 squares, it's 1 times 6 and 2 times 3. So we have 1, 2, 3, and 6. For 7 squares, it's 1 times 7, so it's 1 and 7. For 8 squares, it's 1 times 8 and 2 times 4. So we have 1, 2, 4, and 8. For 9 squares, it's 1 times 9, 3 times 3. So it's 1, 3, and 9. For 10 squares, it's 1 times 10 and 2 times 5. So it's 1, 2, 5, and 10. The rectangles in the mini lab illustrate prime and composite numbers. So if we look at the number 2 and we look at our squares, the factors are 1 and 2. 3, the factors are 1 and 3. 5, the factors are 1 and 5. 7, factors are 1 and 7. And those are all prime numbers. And a prime number is a whole number greater than 1 that has exactly 2 factors of 1 in itself. So then we look at the squares for 4. We had 1, 2, and 4. 6, 1, 2, 3, and 6. 8, 1, 2, 4, and 8. 9, 1, 3, and 9. 10, 1, 2, 5, and 10. A composite number is a whole number greater than 1 that has more than 2 factors. Then we had 0 with many factors and 1 with 1 factor. And the numbers 0 and 1 are neither prime nor composite. Identify numbers as prime or composite. 17, we have one option, right? 1 times 17. The number 17 only has 2 factors, 1 and 17, or 1 in itself, so it is prime. 12, well, we can do 1 times 12. We can do 3 times 4. Or we can do 2 times 6. So 1 times 12, 3 times 4, 2 times 6. The number 12 has 6 factors, 1, 2, 3, 4, 6, and 12. So it is composite. Check your progress. Identify numbers as prime or composite. 11, 1 and 11, so it's prime. B, 15. Hopefully you recognize right off the bat that 5 will go into it, and 5 is not 1 or itself, so we know that that's going to have multiple factors. So it's composite. And 24 is even. So even number that isn't 2, we know is composite. Scaffolding questions. Factors are multiplied together to get a product. What are the factors of 6? 1, 2, 3, and 6. What are the factors of 10? Well, we know 1 times 10 and 2 times 5. So 1, 2, 5, and 10. What are the factors of 18? Well, we know 1 and 18. How about 2? 2 will go with 18 because it's even. So 2 and 9. And then 18 is a multiple of 3. So we have 3 and 6. So we have 1, 2, 3, 6, 9, and 18. What are examples of numbers with only 2 factors? So numbers with only 2 factors are prime numbers. So some examples are 2, 3, 5, 7, and 11. Every composite number can be written as product of prime numbers. So the product is a prime factorization of the number. And you can use a factor tree to find prime factorizations. The following 2 factor trees show the prime factorization of 60. So we have 60, and we know that 6 will go into 60 times 10. And then 6 can be factored into 2 times 3. And 10 can be factored into 2 times 5. And you can choose any other pair of factors of 60. It doesn't have to be 6 times 10. So if we look at this one, 60, and we have 12 times 5, and we could do 3 times 4 times 5, because 5 is prime, and then 3 is prime, so we'll bring that down, then we'll factor 4, 2 times 2, and then 5. So bring down these factors. So we have 2 times 3 times 2 times 5. And they are the same, just in different order than the factors to the right. The prime factorization of 60 is 2 times 2 times 3 times 5. or we can rewrite it with exponents to be 2 squared times 3 times 5. It is important when we list our prime factors that we put them from least to greatest. Find the prime factorization of 24. Method 1, use a factor tree. So we have 12 times 2. And then if we factor 12, we get 4 times 3. We have to bring that 2 down. And then we're going to factor 4. And we get 2 times 2 times 3 times 2. And if we divide the prime numbers, so if we do 24 divided by 2, we get 12. And we know 2 will go into 12 6 times. So then if we want to divide 6 by 2, we get 3. So the divisors are 2, 2, 2, and 3. Prime factorization of 24 is 2 times 2 times 2 times 3. Or we can rewrite it with exponents 2 cubed times 3. Choose your method, the prime factorization of 18. We'll use a factor tree of 18. We have 9 times 2. And then if we factor 9, we have 3 times 3 times 2. And then we could do the divide by prime numbers, which is 18 divided by 2 is 9. 9 divided by 3 is 3. The divisors are 2, 3, and 3. So the prime factorization of 18 is 2 times 3 times 3, or we can rewrite that as 2 times 3 squared. Choose your method, find the prime factorization of 28. Use a factor tree. 28, 14 times 2, 7 times 2 times 2. Divide prime numbers. 2 times 28, or 28 divided by 2 is 14. 14 divided by 2 is 7. So the divisors are 2, 2, and 7. And the prime factorization of 28 is 2 times 2 times 7, or 2 squared times 7. And find the prime factorization of 16. Use a factor tree. 16, we can do 8 times 2. We can factor 8 into 4 times 2, bring down the other 2. Then we'll factor 4. 2 times 2 times 2 times 2. And if we look at 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. So divisors are 2, 2, 2, and 2. And the prime factorization of 16 is 2 times 2 times 2 times 2, or 2 to the 4th power. Factor an algebraic expression. So factor 6ab. If we have 6ab, we'll factor that 6 times ab. Then we'll factor 6 to be 2 times 3. And we'll factor ab to be a times b. So our factorization of 6ab is 2 times 3 times a times b. Check your progress. Factor 18xy. 18xy, we'll do 18 times xy. And then 18 we'll factor as 2 times 9. And xy will factor as x times y. 2 times, we'll factor 9 as 3 times 3. And then we still have x times y. So we have the prime factorization of 18xy is 2 times 3 times 3 times x times y, or 2 times 3 squared times x times y. Additional examples: determine if each number is prime or composite. 63. Composite. 1 times 63, 3 times 21, or 7 times 9. 29. Prime. 1 times 29. Find the prime factorization of 100. So we have 4 times 25. We can factor out 4 to 2 times 2, and 25 to 5 times 5. Prime factorization of 100 is 2 times 2 times 5 times 5, or 2 squared times 5 squared. And 4, find the prime factorization of 21m squared n. So 21m squared n, we factor that out, we have 21m squared n. Then we factor 21, we have 3 times 7. And if we factor m squared n, we have m squared times n. And then we bring down 3 and 7, and we factor m squared into m times m. Then we bring down the n. And the prime factorization of 21m squared n is 3 times 7 times m times n. And here's your homework tonight. Go to Google Forms to submit it. Thank you and have a great day.